In this demonstration, we will show two procedures used routinely to place kidneys on the device for machine perfusion. The kidney on your right was retrieved with a normal Corel patch, and we will use a disposable perfusion cannula for placement on the device. The kidney on the right has no Corel patch. The kidney was procured without a patch, and therefore a disposable or stainless steel clamp cannot be used. And therefore we will directly cannulate the kidney on the left. First, I'll demonstrate the process for placing a disposable clamp on the renal artery. Using pickups, you bring the Corel patch up through the disposable clamp, and fashion the cuff to fit within the confines of the clamp. Close the clamp, centering the orifice of the artery, making certain that there is some cuff exposed on all areas of the clamp. Use the restraining screw to place the clamp, and now this kidney is ready to be placed on the arterial port of the cassette. In our other example, since we have no Corel patch, we must directly cannulate the renal artery. I've previously prepared the artery, and I will place the cannula directly into the renal artery. And using a silk tie, I'll actually tie down on the Teflon cannula. At this point, the renal artery is prepared, and we can place each of these kidneys on the preservation device. I also want to make a note that there are occasions when a particular kidney has multiple arteries. An accessory device called a trident, cannula, or adapter can be used for up to 3 arteries on one kidney. As you can see, the trident is capable of being attached directly to the cassette, and multiple cannulas and clamps can be placed on a single trident. At this point, the cassette is ready to be checked for integrity. The perfusionist should now go and wash his or her hands and don surgical sterile gloves. The next step in the process is to introduce the cassette into the control unit. The cassette can only be placed into the control unit one way, matching the square insert with the bubble trap on the cassette. Once the cassette is placed in the unit, the exterior of the cassette is no longer sterile. Only the internal component remains sterile. It is important to note that the sterile area where the cassette was removed is still a sterile space, and that will become important in a moment. The final instruction in the placement of the cassette is to connect the cassette to the control unit. So now I will add the water to the reservoir and initiate the cooling process. As you may remember, when we left the machine, it was in the pre-cooling process. So when we moved to dissect the kidneys and place the clamps, the device cooled to 5 degrees centigrade. At this time, the perfusionist will be directed to place the sterile drape in preparation for kidney placement. To perform this process, the lids will be removed just as when the machine perfusate was decanted into the sterile canister. After donning a gown, mask, and gloves, the perfusionist will remove the outer lid and place it on the sterile table. The inner lid should be removed sterilely and placed on the sterile table. At this point, The sterile drape, which has been on our sterile back table, can be placed in the cassette. The sterile drape is designed to fit inside the grooves on the cassette. Carefully open the sterile drape. Covering all aspects of the device. Then the drape itself can be locked in place. After the cassette drape has been placed properly, you should confirm that the drape is in place. The next instruction is to place the kidney in the cassette. This can be performed in two ways. Either you can perform the placement directly in the cassette, or you can remove the kidney platform, take it to the back table, place the kidney on the platform, and then bring it back to the cassette. I prefer placing the kidney on the platform while it is in the actual cassette. The platform can be locked into place above the machine perfusate. The restraining net is then moved away from the platform. The kidney is brought over to the device and placed on the platform. At this point, the device has reduced the pressure to approximately 20 millimeters of mercury so that the kidney will not be overpressurized, but it does allow for some flow through the arterial port. The first step is to remove all air from the renal artery and the clamp. Once the air is purged, simply place the clamp into the silastic tube. Then you check for leaks. There should be no leaks around the clamp. Then the retraining mesh can be clamped across the top of the kidney, holding it in place, and the kidney can be dropped down into solution. Once the device is in perfusion mode and the kidney is being perfused, the sterile drape can be removed using aseptic technique. To perform this procedure, simply grasp the sterile cassette and remove the cassette to a dirty space. With clean gloves, place the sterile inner lid, followed by the sterile inside of the outer lid, and lock the lid in place. The kidney is now in the preservation device, and we can move toward the monitoring and evaluation protocol. As you can see on the monitor, all of the information that the clinician needs to make a decision regarding the use of the organ at the time of transplant is displayed. The organ ID number, the perfusion temperature, which ranges between 4 and 6 degrees centigrade, the systolic, diastolic, and mean pressures, the flows, which are measured directly by the transonic flow probe, and finally, the renal resistance. These parameters, in addition to organ biopsy information and donor information, can be used to assist the surgeon as they make decisions about the potential for transplant. The device also allows the operator to be able to change pressure by touching the systolic pressure, which unlocks the screen, and you can move the pressure to any designated pressure, and the system will compensate. In manual mode, the operator adjusts the pressure. In automatic mode, which can be selected here, the pressure is dictated by the device. In other words, as the organ begins to open up and the systolic pressure falls, the device compensates, bringing the pressure back to the set systolic pressure. In addition, there are several options, including trending information, which allows the perfusionist to look at pressure, flow, renal resistance, and temperature throughout the process. One of the unique features of this device is the ability to remotely monitor the device without being present where the device is located. As I told you earlier, the device can be networked using an Ethernet line, and then the perfusion information can be monitored from any networked PC, tablet, or cellular telephone. This allows the surgeon or perfusionist to be able to perform other duties while continuing to monitor the kidney during the perfusion process. And now we want to spend a moment concentrating on the power supply and the input and output area on the device. Of course, the device can be powered by AC power and also by lithium-ion battery in the battery compartment here. There are 4 lithium-ion batteries that can power the unit in the absence of AC power. In addition to the power supply, this is an area where the networking capabilities are integrated with the device. As you see here, the Ethernet line allows you to network the device to your computer system. In addition, there is a USB port that allows for you to transfer information to a memory stick for transfer into your information system. As a safety measure, the circuit breakers are placed in the input and output power area. And finally, the on-off button for the device is placed in this area.